Welcome to Networks Professionals.
Let's jump right into this explainer because today we're looking at something pretty amazing. How does a single, unassuming network cable carry both heavy data cargo and actual electrical juice at the exact same time? Well, we are unpacking Power over Ethernet, a technology that's quietly but massively reshaping how we design our buildings, our offices, and our networks. It is literally making that old spaghetti mass of wires a thing of the past. To really understand why this matters, picture a very common and, honestly, a very frustrating scenario. Let's say you need a security camera up on a 20-foot ceiling, or maybe you need it attached to the outside corner of a brick building. In the past, you couldn't just mount the camera and call it a day. No way. You had to hire a certified union electrician, pull heavy-gauge copper wire through the walls, install a bulky outlet, and make sure every single thing was up to strict, high-voltage electrical codes. And then, on top of all that, you would have an IT pro run a completely separate data cable just to connect that camera to your network. I mean, the cost difference between pulling low-voltage data cable and high-voltage electrical wire is absolutely staggering. It was expensive, it was painfully slow, and frankly, it was a massive logistical headache. The contrast here is just stark. The old way requires doubling your effort with separate data and electrical runs. It's a redundant mess that inflates budgets and timelines. But the Power over Ethernet approach, it acts like an elegant multi-lane highway. You use just one single standard network cable, like a Cat5e or a Cat6. One cable to do both jobs. It streams your high-speed gigabit data, and it delivers the exact electrical juice needed to power the device completely simultaneously. You are literally sending electricity over the exact same copper strands that are carrying your 4K video feeds. It's brilliant. So the crucial point here is that PoE entirely eliminates the need for that separate electrical wiring. By taking those standard, really inexpensive network cables that are probably already running through the walls of your building right now, this technology beautifully bridges the gap between the digital world and the physical power grid. You just plug a device in, it boots up, and it connects to the network in one swift click. It turns standard Ethernet from just a simple data pipe into a truly universal power delivery system. Section 1. The Anatomy of PoE, Sourcing and Receiving. Okay, so let's break this down. Think of this setup as a pure supply and demand relationship. On the supply side, we have power sourcing equipment, or PSE. This is the actual hardware actively injecting the direct current voltage into the network cable. Common examples of this would be PoE switches. Now, these look exactly like your standard enterprise network switches, but they have heavy-duty power supplies built right in. Or you might see PoE injectors, which are these small inline adapters you can actually splice right into a non-PoE network line to give it that necessary power boost. Then, on the demand side, we have the consumer, the powered devices, or PD. These are the network endpoints that receive both the data and the power to actually function. Think cameras, phones, card readers. Basically, without the PSC supplying the precise amount of juice, the PD is just an expensive paperweight waiting for a spark. Section 2. Rules of Engagement. Safety Standards. Now, you might be wondering, isn't combining electricity and data on one cable a little risky? Well, to ensure you don't accidentally fry your very expensive networking equipment by sending raw electricity down a data line, the IEEE mapped out a really clear, heavily regulated progression. They engineered this brilliant protocol, basically a handshake, where the switch actually tests the connection first. It checks to see exactly how much power the device needs before sending the full load. So phase 1, the 802.3 AF standard, that was the baseline, safely delivering up to 15.4 watts. But, as devices got significantly smarter and way more demanding, phase 2, which is commonly known as PoE+, pushed that limit up to 30 watts. And today, with phase 3, or PoE++, we're safely pushing a massive 90 watts over standard Ethernet. This evolution is profound because it means you can run highly demanding electronics, things that used to strictly require dedicated AC power, safely over low-voltage cables without any risk of melting your infrastructure. Section 3. Real-world impact, cost, flexibility, and freedom. Moving away from all those technical standards, the absolute biggest takeaway here is the sheer freedom of deployment. Because you completely bypass the need for separate electrical wiring, you're drastically cutting down installation costs and timelines. You are no longer chained to the existing footprint of AC wall outlets. If you want a device on a high ceiling, maybe hidden in an HVAC duct, or on a remote outdoor pole, well, as long as you can route an Ethernet cable there, you're in business. And honestly, one of the most brilliant aspects is the centralized management. Because all these remote devices draw power directly from a managed network switch in your server room, you have ultimate control. Let's say a camera freezes halfway across a massive university campus. You don't need to send a technician with a ladder to go physically unplug it. No, you can just hard reboot that specific hardware by toggling the switch port power right from your laptop. It's a total game changer.
Thinking back to our initial 20-foot ceiling problem, this is exactly how modern surveillance is seamlessly deployed today. IP security cameras inherently need to be placed in areas that give the absolute best possible vantage point, right? And that almost never coincides with the locations of standard wall outlets. Power over Ethernet allows security and IT teams to place their eyes in the sky exactly where they need them, whether that's indoors or out, with just one simple low-voltage cable pull. It essentially makes the IT guide the hero, letting them completely bypass the wrath and the costly scheduling delays of angry electricians.
But it's not just about remote ceilings. It profoundly cleans up our immediate workspaces too. Take voice over IP desk phones. They are the standard in almost every modern corporate office environment. Before PoE, every single desk phone required a clunky, ugly AC adapter plugged into a dust-covered power strip somewhere beneath the desk, plus a totally separate network cable running to the wall jack. It was a tangled nightmare. Today, one neat Cat6 cable runs from the wall directly into the phone, delivering crystal-clear gigabit voice data and all the steady power it needs. It's just an elegant, instant solution to desktop clutter. And it also effortlessly blankets entire buildings in enterprise-grade Wi-Fi by powering access points tucked away high above our heads. To get perfect wireless coverage in a massive warehouse, a high school gymnasium, or a sprawling open-plan office, you need these hotspots mounted high up, completely free from physical obstructions. And just like with the security cameras, there are rarely electrical outlets hiding up in the acoustic ceiling tiles. PoE allows teams to easily deploy these critical nodes. And as IoT, the Internet of Things, absolutely explodes, we're seeing this same exact infrastructure power smart building sensors, automated window shades, and even entire office LED lighting grids, all running effortlessly off Ethernet. So, as we wrap up this explainer, I want you to take a look around your own workspace right now. We've seen how power over Ethernet brilliantly collapses two complex, expensive infrastructure needs into one highly elegant universal cable. It saves enormous amounts of money, it significantly boosts fire and electrical safety, and it completely untethers our technology from the tyranny of the traditional wall outlet. So, as these standards continue to push higher and higher wattages over incredibly simple copper Ethernet, what clunky, heavy power cords currently hiding under your desk will be the absolute.
Thanks for watching.